Imagine for a moment that you are standing completely alone on this freezing, totally desolate expanse.
Right, just total isolation.
Exactly. There's literally no sound except for, like, this thin, high-pitched howl of a toxic wind.
A very harsh environment.
Yeah. And all around you, stretching all the way to the horizon, is this shattered landscape. Just jagged, rust-colored rocks and ancient dust that hasn't been disturbed in forever.
It's a place completely devoid of life where, nature only really operates through slow aeolian erosion over millions of years.
Right, exactly. Every single rock you look at is fractured, it's asymmetric, it's heavily weathered by the elements. But then you cast your gaze down into the red dirt and you see it.
The anomaly.
Yes. Sticking out of the ground is something that just completely shatters the illusion of this untouched wilderness. It's perfectly smooth.
And bright.
Yeah, it's really bright. It has this flat, clearly machined end. It is a flawless geometric cylinder. It absolutely, fundamentally just does not belong there.
It really stands out.
It does. You're looking at a photograph taken millions of miles away on the surface of Mars, pulled straight from NASA's public image archives. And, your immediate instinct is that you're looking at something manufactured.
Which is exactly why we're looking into this today.
Right. Our mission for this deep dive is to take this exact anomaly, strip away all the wild internet speculation, and look strictly at the hard data.
The optical and telemetry data, yeah.
Exactly. We need to figure out what this object actually is, how it was discovered, and why it has sparked such intense scientific debate.
Okay, let's unpack this, because this specific photograph really forces us to confront some fascinating realities about how we do science on another world.
It really is the ultimate visual contradiction.
Oh, totally.
Because when you're analyzing an environment entirely defined by chaotic geology, specifically the sulfate-bearing bedrock and the jagged terrain of Gale Crater, finding a piece of perfect, rigid geometry, well, it immediately triggers an anomaly protocol in your brain.
It sets off alarm bells. Exactly. And to really grasp the contrast, we have to pinpoint exactly where this was captured. So the date is August 7th, 2022.
Okay.
And NASA's Curiosity rover is carefully navigating this highly challenging, narrow passage known as Paradpui Pass.
Which is located right on the slopes of Mount Sharp.
Yes, deep within Gale Crater.
And navigating Paradpui Pass is, it's no joke. The rover isn't just cruising over smooth sand dunes.
Not at all.
This is an incredibly rugged topographical bottleneck. It's surrounded by these towering hills, and the ground is thickly layered with abrasive Martian regolith and sharp boulders.
Precisely. It's an unforgiving terrain that requires meticulous routing by the rover driving team back here on Earth.
So they have to be super careful.
Very careful. And it's right there, partially embedded in that ancient fractured rock, that the cameras capture this object. Based on the photometric analysis, the object exhibits a remarkably high albedo.
Meaning it's really reflective, right?
Right. It's reflecting sunlight at a much higher intensity than the surrounding oxidized iron landscape. It measures roughly 20 centimeters in length, so about 8 inches.
Okay, pretty small then.
Small, yes, but it possesses this uniform cylindrical shape with a distinctly flat cap.
The visual contrast is what really gets me.
Oh, it's striking.
Yeah, like, if you're an avid hiker, think about trekking deep into the most isolated, rugged slot canyons in Utah.
Just miles from anywhere.
Right. You're days away from civilization, surrounded by nothing but scoured sandstone. And then you look down, and half buried in the sand is a perfectly unblemished silver soda can.
It's jarring.
It completely breaks the immersion of the geology. It screams that artificial processes are at play. And that is exactly what this 20-centimeter cylinder looks like, sitting in the dust of Paradpui Pass.
That's a really highly accurate framing. Geometry stands out against entropy.
Yeah, that's a good way to put it.
And that specific feeling of, this defies the local geology is what actually drove the discovery. Because, and this is a critical detail in the data, it wasn't the primary engineering team at the Jet Propulsion Laboratory who initially flagged this.
Wait, really? Because that completely flips our standard assumption of how planetary science operates.
It really does.
Like, we tend to picture a room full of NASA scientists staring at a massive screen, analyzing every single pebble as it downloads.
Like in the movies.
Exactly. But the volume of data coming down from the Deep Space Network is just too massive for that, isn't it?
Oh, it's staggering.
Yeah.
Curiosity alone has returned hundreds of thousands of raw images.
Wow.
And NASA pipelines these raw frames directly into the publicly accessible planetary data system almost immediately after they are received. What's fascinating here is how the democratization of this raw telemetry has fundamentally altered planetary exploration.
Because anyone can look at it.
Exactly. You have a global network of highly dedicated citizen scientists downloading these raw files. They're stretching the image histograms and meticulously scanning for albedo anomalies or morphological outliers.
Things that a busy engineering team might just scroll right past.
Right, because the engineering team is primarily focused on the rover's immediate safety and its primary geological targets.
I find that incredibly cool. You have people sitting at their home computers, running their own image processing software on raw Martian telemetry.
It's crowdsourced science.
Yeah, and they are the ones raising their hands to say, hey, JPL, why is there a machine cylinder on Mount Sharp?
Exactly.
But before we dive into the theories of its origin, I have to step in with the most cynical, scientifically necessary pushback.
I think I know where you're going with this.
Well, you and I both know how tricky digital imaging can be, especially in a high radiation environment like Mars. My immediate thought when I saw the image wasn't alien artifact or rover debris.
No.
No. My first thought was, that's a cosmic ray hit.
A very logical first assumption, honestly.
Right. Mars has a fraction of Earth's atmosphere and no global magnetosphere to deflect high-energy particles.
So the radiation is intense.
Yeah, we know that cosmic rays constantly bombard the camera's CCD sensors, causing dead pixels or bright streaks that look like physical objects but are actually just hardware glitches.
Or it could just be a piece of dust.
Exactly, dust clinging right to the camera lens itself. So how do we definitively prove to you, the listener, that this isn't just an optical illusion or a digital artifact?
What's the essential triage process in planetary imaging? You basically have to actively try to disprove your own eyes.
Okay, so how do they do that?
To do that, we have to look at the specific optical mechanics of the hardware that took the photo.
Specifically, Curiosity's masked camera system, or MASCAM.
The big cameras on the head of the rover.
Right. And this isn't a single flat field camera. It is a stereoscopic system consisting of two separate cameras, a left eye and a right eye mounted right next to each other on the rover's mast. Okay, so it's capturing depth using parallax, just like human vision.
Exactly like human vision.
Let's make this concrete for you listening right now. If you hold your finger up in front of your face and close your left eye, then your right eye, your finger appears to jump back and forth against the background.
That geometric shift is the parallax.
Right. But if you have a smudge right on the lens of your glasses, it doesn't shift at all. It stays dead center in your vision regardless of which eye is open.
That is the exact principle at play here. When the image processing specialists analyzed the data for this 20-centimeter cylinder, they looked at the stereo pairs.
The image is taken by both cameras at the same time?
Yes, the simultaneous images from the left and right mass cams. And the object exhibits the precise, mathematically expected parallax shift for a physical object resting on the ground at that specific focal distance.
Oh, wow.
Furthermore, as the rover translated across the surface and took subsequent images from new vantage points, the object's geometry and shading changed consistently.
Meaning the shadows moved.
Exactly. It behaved consistently with a three-dimensional shape illuminated by a directional light source,
right,
which, is the sun.
So that instantly rules out the sensor glitch or the lens dust.
Completely.
Because if it were a cosmic ray strike on the sensor, it would only appear in one camera's frame, and it would just be a flat, bright pixel cluster.
And if it were dust on the lens, it wouldn't demonstrate parallax.
Right. It would move with the mast, not stay anchored to the Martian bedrock. Here's where it gets really interesting, because by confirming the physics of the photograph, you entirely close the door on the easy explanation.
We certainly do.
We can't wave it away as a digital glitch. We are forced to reckon with the physical reality of a smooth, machined-looking cylinder resting on an alien world.
It's a real, tangible object.
So, since the stereoscopic data proves it's real, and its geometry completely defies the natural chemical erosion processes of Gale Crater, what is the actual scientific consensus on its origin?
Well, when you eliminate natural geological processes and digital artifacts, you are left with artificial manufacturing.
Which is where everyone's mind goes wild.
Naturally. And while the internet loves to leap toward extraterrestrial origins, the prevailing consensus among planetary scientists analyzing the telemetry is much closer to home.
Okay.
The most highly probable explanation is that this is human-made material. Specifically, It is debris from our own spacecraft.
Okay, let's really dig into the mechanics of that, because on the surface, it sounds crazy that we just leave pieces of our multi-billion-dollar rover scattered around.
Does sound counterintuitive.
It does, but think about the extreme thermal and mechanical stress Curiosity is under. We are talking about a 1-ton nuclear-powered laboratory crawling over jagged rocks.
And it's not just the physical beating of the suspension.
Right, the thermal cycling on Mars is incredibly violent. The temperature can swing from negative 130 degrees Fahrenheit at night to above freezing during the day.
That thermal cycling is a massive factor in material degradation.
Yeah, if you subject aluminum, titanium, and various polymers to that kind of extreme expansion and contraction every single day for over a decade, because Curiosity landed in 2012, you are going to experience severe metal fatigue.
Parts are bound to fail.
Exactly. A bracket is going to snap, a cable casing is going to split, a bolt is going to shear off. Think of it like taking an off-road vehicle on a really brutal trail.
Right, you're bouncing over boulders and washboards.
Yeah, and you're going to lose a hubcap. Or a loose bolt just vibrates off along the bumpy trail, except this off-roading is happening millions of miles away on another planet.
An excellent analogy regarding material degradation. And it certainly accounts for a portion of the wear and tear we see on the rover, like the well-documented holes punched in its aluminum wheels by the sharp bedrock.
Those wheel pictures are rough to look at.
They really are. However, when evaluating a 20-centimeter cylindrical object like this one, we also have to look beyond the slow degradation of the rover itself.
What else is there?
We have to examine the catastrophic mechanics of how the rover actually arrived at Gale Crater in the first place.
Oh, you're talking about the landing sequence, the infamous 7 minutes of terror.
Exactly. We need to remember that getting a 1-ton payload to the surface of Mars requires a choreographed sequence of incredibly violent, explosive events.
Because landing on Mars is famously difficult.
Mars presents a unique aerodynamic problem. Its atmosphere is thick enough that you have to use a heat shield to survive entry, but it is far too thin, about 1% the density of Earth's, to actually slow a heavy object down to a safe landing speed using only parachutes.
So you can't just float down gently?
No, you cannot.
You have to bleed off thousands of miles an hour of kinetic energy in just a few minutes, or you basically become a crater.
That is the engineering hurdle, and overcoming it generates an enormous debris field. First, the spacecraft hits the atmosphere at over 13,000 miles per hour.
That's insanely fast.
It is. The heat shield, which is made of a specialized phenolic-impregnated carbon ablator, experiences temperatures approaching 3,800 degrees Fahrenheit.
Wow.
And the very nature of an ablative heat shield is that it is designed to burn away, shed material, and eventually be explosively jettisoned.
So it just falls away?
Yes, it free falls to shatter on the Martian surface.
So right there, before the rover is anywhere near the ground, we are already dropping massive chunks of engineered materials, heat tiles, and explosive bolts from the sky.
And it only gets more aggressive from there.
How so?
Well, after the heat shield is gone and the supersonic parachute is cut away, the spacecraft initiates powered flight. This is the sky crane maneuver.
The rocket jetpack.
Exactly. A hovering rocket jetpack fires 8 hydrazine thrusters to kill the remaining velocity. It then literally lowers the rover on long nylon umbilical cables.
Like a crane.
Right. Once the wheels touch down, pyrotechnic guillotine charges fire, instantly severing the cable.
Just chopping them off?
Yes. The sky crane then throttles up and flies away to intentionally crash land at a safe distance so it doesn't damage the rover.
When you break down the actual physics of that descent, the pyrotechnics, the snapping cables, the ablative shielding, the intentional crash landing of a massive rocket sled, it's actually a statistical miracle that the immediate area isn't completely littered with shiny metal cylinders and sheared bolts.
It is a highly kinetic, truly chaotic delivery system. And this brings us to the crucial precedent that informs the scientific consensus.
Which is?
We have a well-documented history of finding exactly this kind of debris on Mars. Throughout the lifespan of both Curiosity and the newer Perseverance rover, optical cameras have regularly captured images of geometric anomalies.
And what did they turn out to be?
They were definitively traced back to the entry, descent, and landing hardware.
Like the thermal blankets, right. I remember seeing images from Perseverance where it looked like a piece of tinfoil was stuck in the rocks.
Yes, that's a perfect example.
And it turned out to be part of the descent stage's thermal insulation that had just blown miles across the crater in the wind.
Precisely. We've found discarded parachute material, jagged fragments of the carbon composite backshell, and shatter pieces of the sky crane itself.
So it happens all the time.
It does. Therefore, when researchers look at the albedo, the smooth finish, and the specific geometry of this 20-centimeter cylinder in Paradapui Pass, the application of Occam's razor leads straight to our own engineering.
It's the simplest explanation.
Exactly. It is highly probable that it is a discarded component of Curiosity's own landing system, or perhaps a piece of the rover itself that succumbed to the thermal fatigue you mentioned earlier, eventually falling off and getting left behind in the dust.
There is a deep irony in that, isn't there?
How do you mean?
We build these incredibly sophisticated optical systems. We send them millions of miles across the vacuum of space to hunt for the tiniest anomalies in the geology, and the anomaly turns out to be a piece of the very machine doing the looking.
If we connect this to the bigger picture, it serves as a really profound metric of our technological reach.
That's a great way to frame it.
While the immediate mystery of this specific cylinder resolves into a mechanical explanation rather than a biological or extraterrestrial one, it forces us to acknowledge the expanding physical reality of the Anthropocene.
We are actually physically there.
Yes, we are no longer merely observing the solar system through the abstract data of orbital telescopes. We are physically interacting with it. The debris fields of our heat shields and the tracks of our rovers are tangible, material evidence that human civilization has extended its footprint to another world.
We are quite literally leaving a trail of breadcrumbs across the inner solar system, which brings up the obvious next operational question.
Go ahead.
If we have this highly unusual, unidentified piece of material sitting right in front of the rover, did Curiosity deploy its robotic arm? Did it use its chem-cam laser to zap the cylinder, analyze the plasma, and definitively tell us, yes, this is an aerospace-grade titanium alloy?
It did not.
What?
Really? It didn't. And this highlights the strict triage involved in planetary mission management. Curiosity is currently continuing its traverse up the lower stratigraphy of Mount Sharp. It's already several kilometers away from the exact coordinates where this shiny cylinder was photographed.
That is going to drive you absolutely crazy if you were a completionist.
Oh, without a doubt.
Like, you find a glaring anomaly, you take a couple of stereo photos, and then you just put the rover in drive and roll away. Why not take a day to zap it with the laser and be 100% sure?
Because rover operations are a zero-sum game regarding time and power. The scientific teams operating Curiosity have a rigorously defined set of geological waypoints they must reach to fulfill their primary mission.
Which is finding out if Mars was ever habitable, right?
Exactly, to analyze the ancient water-bearing rock layers of Mount Sharp. Taking a multi-day operational detour to definitively identify a 20-centimeter piece of suspected spacecraft debris simply doesn't yield enough scientific value.
It's not worth the battery life.
Right. It doesn't justify delaying the analysis of a crucial clay-bearing geological unit. The probable answer spacecraft debris is high enough that they can confidently move on.
So what does this all mean? If we look back at the trajectory of this entire deep dive, we started with an image that intuitively felt like a glitch in reality.
A total contradiction to the landscape.
Yeah, a perfect machine cylinder sitting in a landscape defined entirely by jagged, wind-scoured rocks. We saw how the democratization of raw data allows citizen scientists to act as the vanguard, right? Spotting albedo anomalies that standard operational sweeps might miss.
It's a huge shift in how we process data.
It is. And then we dove into the optical mechanics of the mast cam, utilizing stereoscopic parallax to definitively prove that we aren't looking at a dead pixel or a camera smudge, but a real, tangible 3D object on the ground.
A physical piece of reality.
Exactly. And finally, we explored the incredibly violent explosive physics required to land a one-ton rover on Mars, realizing that the most scientifically sound explanation is that we are looking in a mirror.
We are looking at our own shedding technology.
Yeah. It's a journey that takes us from the edge of wild internet speculation right back into the fascinating realities of aerospace engineering and material science.
It perfectly encapsulates the scientific method in planetary exploration. We observe an anomaly, we test our assumptions against the physical limits of our hardware, we look for historical precedents within our own mission parameters, and we arrive at the most probable, mechanically sound conclusion.
It really does. And it leaves me with one final thought, something for you to mull over long after you finish listening to this deep dive.
Oh, what's that?
Well, we've established the high probability that this is human-made debris. A tiny fragment of a 21st century entry, descent, and landing system left behind in the red dust. But expand your timeline. Think about a distant future.
Like hundreds of years from now.
Yeah, maybe 200 or 300 years from now, when humans have established a permanent presence on Mars. When geologists in pressure suits are physically walking the stratigraphy of Mount Sharp, how will those future generations interact with these scattered pieces of metal?
That's a fascinating question.
Will they view this 20-centimeter cylinder and the shattered remnants of our sky cranes as annoying historical space trash that violates planetary protection protocols and needs to be swept into a recycling smelter? Or will they treat these debris fields as sacred ground?
Like a historical site.
Exactly. Will they erect physical barriers around them, protecting them as priceless archaeological artifacts? It's entirely possible that what we currently classify as discarded aerospace debris will one day become an open-air museum,
Preserving our early history.
preserving the very first tentative, deeply clumsy mechanical steps humanity ever took into the cosmos. It fundamentally shifts how you view the concept of a footprint. Keep looking closely at the details in the data, because what is just a loose bolt today might be the cornerstone of a museum tomorrow.